Hi everyone, in today's video we're going to have a look at quality control and quality assurance for your exam content. This typically will appear in paper 1, the 2.5 hour paper that you're doing, because it goes along with the manufacturing of products. So I'll go through what's expected in the exam stuff for you, but typically quality control, quality assurance will probably be like a part B or a part C of a bigger question, or it might be a simple case of like a definition of what it is and explain how it's applied to a manufacturing process. So first of all, just a definition of the two, because the most common thing people get wrong really is they confuse quality control and quality assurance. So quality control is basically how like checking things that are done correctly. So during the manufacturing process, whether you're making a single item or if you're making like 1,000 or 10,000 of them, is what are you actually checking? So basically, throughout that whole process, you don't just start the process of making it, then you finished, and then you try and sell it. Throughout the process, you'll make sure you check at certain times to check that it is done correctly. Because if you don't, then the whole thing is wasted. You have to chuck it away. Obviously, if you're making like a single thing, like you do with your coursework, it's easy to do because I've drilled those holes. Are the drills in are the holes in the right place? Yes. Okay. Good. Move on. Whereas if you're making like a batch or mass production like sized sort of things, is you can't check every single one. So what you'll do is you'll check a quantity of them. So say you're making 1,000, what you might do is check every 50, and then or even less than that, maybe every 25. And then what will happen is if one of those 25 fails one of the checks, then that whole 25 you have to just like bin and you have to make another set. So slightly different if you're making like a one-off compared to mass production, but you're still checking. So what you can check for are things like accuracy of dimensions, and you can use things like jigs to check that sort of thing, check the weighting of it, check flammability, check that it's fit for use, trying to meet all these particular standards that you've set out. Quality assurance is what do you actually do um, to check to make sure it's done correctly. So how do you assure that it's done? So that'll be the things you set up before. So what you will be doing is making sure you've got the correct material, you've got the correct dimensions. There's no um, flaws in the material. So you're working with like natural timbers. There's no knots in it. It's not bowed. It's not warped. Those sorts of things. Checking your equipment, checking it's working correctly, checking you got the right molds, checking you got the right size drill bit. I'm imagining there will be students listening to this that you've gone to go drill a hole, you just assumed whoever was using the pillar drill last time was using the same size drill as you, you've drilled the wrong hole. Okay, you'd be surprised how often that happens. Because I didn't check, but you need to check your equipment. And then I said just making sure that your staff are trained. Obviously, I train you in the workshop specifically, but also if you are running a company and your employees are making a thing, you want to make sure that they are making it correctly. You then, along with quality control and quality assurance, you've got tolerances. Now, we will come up with tolerances a little bit later as well, just to sort of go over it. But tolerances basically, you can't always guarantee that something is going to be exactly the size that you want it to be. Okay, so in this instance here, we've got like a bolt. Okay, you can say, look, this is the ideal size, whatever it may be, 25 mil or something like that. Okay, but you allow a tolerance above or below what that could be to like except that during the manufacturing process it might have been slightly off. So they could be to do with the diameter of something, it could be to do with the weight of something, but you decide during the process that you're allowed a little bit of give, a little bit of tolerance about what would be acceptable. So like in this example here with the bolt, the tolerance here is plus or minus 0.5 millimeters. So that means that say it was meant to be 25 mil, it could be 25.05 mil, or it could be 24.95 mil. I'm sorry, I was really bad maths there. Excuse me. So some products have tighter tolerances. When we say tighter tolerances, that means it has to be a lot more accurate. Some ones have looser tolerances. If there are a lot of moving parts like engines, they tend to have tighter tolerances because things matter because of how it moves together. Actually, historically, one of the better pieces of engineering to do with looser tolerances, actually, and this will be like all the gaming geeks will like this, is the AK-47, the Russian machine gun notoriously had quite a large tolerance with parts because it meant that it could work in all conditions. So basically, it didn't matter. Things weren't getting jammed as much as, say, British or American engineering of weapons because the Russians made it in such a way that the tolerances were a little bit looser. So if gunk and things got into it, it would still work. So it's actually considered being one of those times where looser tolerances sometimes does help. Okay, so quality assurance in terms of some symbols. Now, most of these, I imagine, you'll see on a day-to-day basis. You might not necessarily know exactly what they mean, um, but they're on pretty much everything. So the first one is the BSI kite mark. So that stands for the British Standards Institute. So essentially, what they do is they will test every product that is made and sold in Britain. It starts off in Britain, hence BSI, British Standards Institute, but actually it's getting quite renowned worldwide as being one of the best in terms of quality. So what companies need to do if they want to sell a product in Britain, they need to have it tested to British standards. If it hasn't met those standards, then it's not allowed to be sold. And if they do try and then sell it, then they're open to lawsuits if someone gets hurt. There have been instances before where companies have not had their things quality checked and there has been serious injury or even death, and have led to lawsuits and actually people being prosecuted and serving jail time. A very, very sad story came out, I think it was 3 years ago, where a company was manufacturing children's cots, and actually a small number of children suffocated because of the poor design and it hadn't been tested. And that person is currently serving a prison sentence because they didn't follow guidelines. So companies have to pay to have their things tested. So it's not like it's done for them. They have to pay to have this done. But it then means once you've passed that you can then sell your thing in Britain. The Lion Mark is normally gone on the British Toy and Hobby Association, so that means that it covers their code of practice. So it's been tested with children's toys. Now each kind of children's toy have different sort of tests. There might be like the flammability test. So if you think like a teddy bear, there are certain regulations about how quickly it's allowed to like go up in flames. So basically, what would mean is a children's toy has to burn slow enough that if it catches fire, a child can drop it and walk away, rather than it going. If it goes up in flames instantly, there's more of a risk of injury. Whereas if it goes in slowly, it means they can drop it and walk away. Same with things like small parts. So they don't fit down trachea like the throat. So if something breaks, but it breaks big enough that you can't swallow it, it's fine. Along with that is that's when you start to get like these sort of symbols here. So if, say for example, it failed the test in terms of a piece that was so small it could be swallowed, they might then decide, okay, well let's put this risk on here so no one under 3 should play with this because that has the risk of people choking. Whereas once they're bigger, less so. And then similar to the BSI kite mark, you then got the CE mark. Now, this stands for Conformity to European. So they are based in Belgium, I believe. I might be wrong on that. But basically, much like BSI is for Britain, the CE mark is for European Union. Now, obviously, Brexit and everything like that, but actually, CE mark still actually is used quite a lot in British products because, again, they are a very, very good mark of quality. Uh, when you go on holiday and you see those dodgy people selling you like Gucci watches and Parmani and all those sorts of fake things, obviously they don't have these markings on there. They might have the sticker, but it isn't real. Excuse me 1 second. Apologies, I have a cold, so if I stop to blow my nose, I apologise for being disgusting. Um, so yeah, the CE mark it's basically the same as the British kite mark, but it's just for Europe. So basically, everyone like Central Europe have products that have been tried and tested, and they meet those certain standards. There's a lot of similarities between the BSI and the CE standards that are done. You can flip a coin about which one is better. We'll say BSI because we're British, but actually they both. Typically, you'll see products in both. So if something has just been tested for the BSI mark, doesn't necessarily mean it can be sold in Europe. So if someone makes a product in Britain and they got the kite mark, they would also have to get the CE mark, CE testing done so they could sell in an international market. And it all comes down to where you want to sell your thing, basically, whatever it may be. It could be a phone, it could be a bottle, it could be a chair, it could be a car, it doesn't matter. Wherever you want to sell it, you have to meet those standards of safety in that market. So just a couple of examples of quality control checks, quality assurance checks that you can have taken place. So we'll take like a standard sort of school chair. So quality control checks will be things like making sure visual checks of faults for materials, checking you've not got any splits or warps, that sort of thing, checking the surface finishes, check the joints are all secure, check the legs and frames are all joined to the seat and back securely so there's nothing wobbling around, they can get hurt. So you have, when we do testing as well, we talked about this on a few other materials testing videos as well, is you do like destructive tests where you'll test it to break it to see what the limits are of like wear and tear, fire, retardation, that sort of thing. And then quality assurance is because you've got like, if you can see there, obviously it's a curved back and base of the chair. They'll have used a former, like a jig, to make that shape. So that quality assurance is they'd use a jig to make sure that you always have the same curve each time. What you don't want to do is have make one chair and then every single chair the curve is slightly more different. So calculator, so quality control. So you have your visual checks for faults in the materials again, and making sure the plastic hasn't cracked, those types of things. Making sure the button panels fit correctly. You got all the surface symbols are all on there correctly. Again, you have the destruction, you check it, wear and tear, those sorts of things. Check for the battery life. Check that the circuit board is all working correctly. And the last one on some greetings cards. So quality control checks you do is you check the print quality, you check that your die cutting is done correctly as well. So the die cutting, if you run for the forming materials, is how they actually cut card out on a bigger scale. Check there's no fault, like the ink hasn't smudged. Check there's no faults in the material, it's not ripped, anything like that. So those are just three random products just to show you the different kind of checks that you can do to make sure that they are done correctly to the right standard. So we talked about BSI, and they crop up in quite a few different theories. So how are standards actually made? So BSI, there are thousands and thousands and thousands of standards. If you ever can't go to sleep at night, just start reading some British standards because it's incredibly long books and folders going through so many different standards of rules that you have to follow. Sorry. So how do these standards get made? So basically, what you'll do, you have a group of industry experts, consumers, research organisers. There may be some government legislation and things like that, of people coming together and deciding what the best standards would be. So if it might be for like children's safety, you might have a few parents come in, you may have other manufacturers come in, you may have other companies come in, and they'll decide what they reckon. Or they might have like doctors come in, for example, as well, and say, okay, we reckon this is the right level of safety that we need, and then that's how standards will be decided. When you see British standards, now these are just a random collection that I've found online. You'll always see BS, British standards. And then there'll be a four-digit number typically. There are some exceptions, so you might have like BS and then sub headings, but there's always like a number of some kind that goes along with it. And that number essentially just refers to whatever it is. You are not expected to be able to memorize British standards numbers off the top of your head. There's a few that can jump to mind and those sorts of things. It depends on what you're doing, but they can be ones so you see things like electrical systems, software testing, structural concrete, travel adapters, IT management. So they cover so many different things. What we have down here as well, you see, is ISO. So ISO is actually the International Standards Organization. So we talked about that in a previous video as well. So along with British standards, along with the CE mark, the ISO is the international standards. Now, they are a lot more general. If you're going to be a global company, you have to meet international standards as well. They are still very, very good, but British standards are kind of seen as having higher standards than them. But as a company, if you want a good reputation and to be able to sell up in loads of different companies, you kind of want to have checks by every single person if you can do. Okay, so we've talked about the CE mark. I don't think I'll go over much. We're not really covered everything else already in here. So we talked about things like Toy Safety Directive and those sorts of things. So we've already covered the CE mark, but yeah, have a look at that. But we'll move on. So in terms of like ensuring accuracy, so we've got a few sort of like measuring devices of things that you can have. So you've got things like digital vernier calipers. You've seen them in the workshop. They are really common in engineering and any sort of manufacturing industry. Most of them are digital now. You can get like analog ones, manual ones that have no digital screen on them. It's how you can check diameters and thicknesses of materials. You've also got digital angle finders, same sort of thing. We don't have any of those in the workshop currently because my last one broke. But that will essentially let you find the angles and check like draft angles of certain types of things. You've also got coordinate measuring machinery. So this essentially will be, if you see this, what this is here, is you can put a component in the middle of a machine and you'll have a 4 or 5 axis arm that will have a sensor that will essentially go around this object and touch each part of it, and it will measure it for you. These are incredibly expensive machines. They're very cool to watch, but if you need to replicate a part, there is no better way to accurately measure it than that way. So you've then also got a go, no go gauge. So we talked about quality control and quality assurances. So quality control can be how you sort of check your parts as you're going along for certain sizes. So what you'll do is you'll have a gauge set up. So it'll just be like a little jig. So you see, like on this, where's my mouse gone? There it is. Down at the bottom here. So you will have a go gauge. So basically you'll say, right, this piece needs to fit within this gap. And what you'll do is you will push the part in. If it fits in and it's not loose and it's not tight and it fits in perfectly, then it goes. If it is not possible to push it in, so it's not possible to push it in by hand, that means it's gone in, fits in fine, good. If it doesn't go, then okay, no good, have to get rid of it. And that's what it basically means, go, no go. So if it fits in the gauge, into the jig, it fits, doesn't wobble, can do it no problem, moves on. If it doesn't fit for a reason, it's too loose or it just doesn't get in at all, then it's no go and it's a faulty product, have to get rid of it. So we've got non-destructive testing. So we have covered this in the previous video of materials testing. So ultrasonic testing and then X-ray testing. So ultrasonic testing, the same way you would check pregnancy, which I assume many of you aren't really aware of. So essentially what you happen is to send ultrasonic waves through an object. If there are no faults, it bounces back and then the wave, so you see this one down here. So it sends the wave down, hits the end and bounces back again. If there are no faults, then the waves stay exactly the same. But if there is a crack or something like that, then it's a much shorter wave. So you see it bounces, comes back, the wave is a lot shorter. So that's how you can tell any defaults, something like that. X-ray works in the same kind of way, but rather you're going to use X-rays going through it, and it will reflect back an image on a screen that will show any defaults that come up. I'm sure many of us have had X-rays. So they say, don't worry, it's completely safe, and they put my bomb disposal outfit on and go and hide behind a giant lead wall. Okay, so flow diagrams. So if you do electronics and possibly engineering, you probably have more detailed flow diagrams. There are a lot more other symbols that exist in flow diagrams, but in terms of the product design related side of things, these are the only real ones you need to know about. So you start with like an oval shape, then you got squares, and then you got diamonds. So basically what happens is any process, and the same works for like AI and that sort of thing, is you always have to map out every eventuality of something happening. So you always have to start with the start and you always have to end with an end, otherwise nothing will happen. Okay, so if there's an action, it is just a square. So in this instance, it's drill a hole using the jig. You did something. Okay, then if you've got a question, has something happened? So this diamond essentially is a check. So we drilled the hole. Is the hole deep enough? Yes, carry on. No, go back round and try again. It could also be something like turn on a light switch. Did the light come on? Yes. Okay, proceed. No. Check again. And what will happen is if the check, there might then be other parts coming off here. So this is actually quite a very basic flow diagram. But then what you'd have to do is if, say, there was faults and you're kind of stuck in a loop, you'd have a sub loop coming off where you have other checks as well. So like I say, if you do electronics, engineering, you may find other extra shapes to do with your flow diagrams, but these are the main ones that you'll come across in product design. So the reason why I'm showing you that now is because what typically I would get you to do is to, in lesson time, is make a flow diagram for making something like a cup of tea or getting dressed in the morning. Because what you need to be able to do is basically do a critical path analysis. This is how you project manage something you are doing. So you wanted to try and reduce as much waste as physically possible. Okay, so waste can even be considered something like you've just wasted time by sitting there not doing anything, or you've had to get up to go and walk and get some material rather than have it more organized and it comes to you, or rather than having it already next to you in a better system. Excuse me. So in this instance, we've got a cup of tea. So a thing like start the kettle. So you have how long it takes. So that's none. So get clean from cup mug from cupboard. Take out to the area. So you say how long it takes, how much effort it is. And then basically, as you go, rather than just standing there waiting for a thing to happen, you go and do other jobs. So if you look down here at the bottom, obviously, if you boil a kettle, you don't just stand there and wait for the kettle to boil. While that is boiling, you then do other jobs. It's the same in your coursework. It's like nothing is more annoying than if someone glues or paints something and then you say, "Oh, what are you doing?" "Oh, I'm waiting for it to dry." So you're going to stand and stare at it for 24 hours while it dries, are you? So it's making sure you are effective with your time. Obviously, if it's just you and doing something in the grand scheme of things, not a big deal. But if you are an employer and you are trying to make money, what you don't want to do is pay employees to essentially sitting around doing nothing, waiting to do something else while they're waiting and not doing anything. So it's trying to make sure you're eliminating as much time wasting as possible to be as proactive as possible. So make it basically rather than getting up and walking to get your materials, is you've got it organized next to you. We've talked about this in the scales of production video where they had the overhead systems in textiles where basically rather than sewing machinists getting up to get new material, the material is delivered to them overhead on all those rails. So how do you ensure quality is consistent? So we talked about like molds. So basically, you've got molds and jigs. Okay. So a jig is something you can use to hold something in place while you do something. Okay. So say you need to like drill a hole in a specific place, you can have a jig that will hold your material and it'll have holes in, so you can make sure that the holes are always drilled in the right place. There are instances in exam questions where it's about making a bike frame and obviously parts of it have to be welded. So how do you make sure it's welded accurately each time? Well, someone can put all the parts in a jig, holds it in place perfectly, and then someone just comes along and welds it in 3 or 4 places, and it's done. Okay, so it's basically helping you guide one, hold it in place, and two, show you where you need to go. Whereas with a mold, essentially that's a hollowed out um, shape of what you want to have, and then you pour your material into it, whether you're pouring in resin, you're pouring silicon, um, all sorts of different things that it could be. So jigs are holding things in place and then guiding whatever cutter or drill or whatever you're using, whereas molds are a hollow caveat of something that you're pouring something into. So we've talked about tolerances a little bit. Funnily enough, there is going to be a tolerances maths video going up on the YouTube channel in a little bit as well. Please do check that out. Um, so you do need to know how to calculate tolerances. So I'll go through that a little bit more in the other video. But essentially what you need to do is figure out the maximum tolerance that you want and the minimum tolerance you want and figure out the difference. So once you've got that difference, so in this instance here, so 0.5 to 0.506. So the tolerance obviously is 6 mil. What you need to do is find out what the prime size, like the actual expected size would be. And then basically, so you take your tolerance, divide it by the original number, and then times it by 100 to turn it into a percentage. There will be a maths video going up. It'll only be about 4 or 5 minutes long, but please do have a look at that because you do need to know how to calculate tolerances. Okay, so Six Sigma. This is basically a system for trying to eliminate as much waste as possible. So there are few different steps to go through. So I'll go through those in here in a second. But essentially, I've just taken this offline of a company that does something called Lean Six Sigma. So essentially, these are sort of the steps that they've said you need to have in them. Okay, so first of all, before you can try and improve everything, obviously you need to observe and check things. So you define the problem, figure out what the issues that you're trying to sort out. So measure, collect data, and figure out whatever it is you're trying to do. Analyze the problem, analyze where the wastage is, see what's going on, have a look at how it can be improved, and then set that up. So that's a bit generic, but let me show you here basically. So Six Sigma, the whole point is you're aiming to reduce the number of defects in a product through monitoring it. So actually checking up on things as much as possible. The word lean, so it said there Lean Six Sigma, basically it refers to trying to eliminate all waste. And as I said, waste could be things like you standing up and going walking over there. I always use an example. If you imagine like in secondary school, We said, "Oh, miss, I need to go to the toilet." And no one ever, we know you never went straight from the classroom to the toilet and back again. You would always go for a little bit of a wander. You'd, "Oh, my friend's in that classroom. Oh, I'm just going to go over here." Okay, that would be the definition of not lean. That would be all the wastage. If you've never gone from A to B, you've gone A to, "Oh, I'm going over here a little bit," and then you come back, and next thing you know, a 2 minute, 5 minute job will suddenly turn into a 15-minute job because it's fun. Why not? So waste, as I say, is identified as anything that does not benefit the client and is given the name mudder. Quite hard to say when you've got a blocked nose. Okay, so there are 7 types of mudder, which basically gives you the name Timwood. They love abbreviations in manufacturing. It's impossible to remember all. So transport. So what you might have is like the risk of damage in transit, or risk of traffic being late, and those types of things. Inventory. So they aim to kind of reduce the amount of stock stored at any one time. So we've talked about this about just in time and trying to have, because if you have too much stock, it can go obsolete over time. Movement around production, so walking around the factory, having all that wasted time as we've talked about. Waiting, making sure that the processes are split evenly so people aren't waiting around doing anything, because as we said on previous slides, nothing will annoy a big important boss more than seeing an employee sat around doing nothing or on their phone, because then what am I paying you for? Overproduction, very much similar to inventory, because what you don't do is overproduce something, because once you've got stock of it, you have to then store it, which then you need to have to pay for a factory, and that suddenly becomes a whole different thing. Overprocessing, so using the right equipment for the job. So we've talked about in other videos as well about manufacturing processes, and normally, sometimes, there's always more than one way of making a product. Okay, but it's finding the right way. What you don't want to do is overcomplicate it or use a really, really expensive process to make something, because it'll work, but you could have done it in a much faster time with a much cheaper process. And then getting rid of any defects of products to be removed. So those are essentially what we consider like the 7 sort of wastes of things that you're trying to reduce to do with Six Sigma. Okay, so what I would like you to do now, pause for dramatic effect, is draw this out in your notebook. And essentially, can you just, for each one, I've already filled out some of these for you, give me a definition or an explanation of what it is. Why is it important in terms of the process? And it could be to do with any sort of example process, and then give me a real life application for it as well. So pause the video, have a look through your textbook, look through notes, and we'll go at that. And then the last thing, I've got a couple of questions for you. So it's on page 292 to 299. Pause the video, and then have a go answering it, and then I'll go through the answers. Okay, so I've not put 2 answers on there because it would be too difficult. There's so many different processes you could possibly have. So just to talk through a couple of these. So explain 3 QA procedures that may be required in use of manufacturing injection molded components. So that would be making sure, checking that you've got the right sized molds, making sure there's no defects in the molds, there's no cracks, making sure they're clean, those types of things. And then quality control checks that you could do to make turn aluminium components. So you could check weight of something, you could check the size of something, and then you could check to see if there are any defects in any material. So there's loads of different possible checks you could have. That's just 3 possible ones. Right, so that is the end of quality control and quality assurances. If you've got any questions, please let me know and I will get back to you. So, first one, list the 6 stages of Six Sigma. First one has been done for you, so 4 marks. So really simple, 4 marks, no explanation needed. Pause the video, give yourself 4 minutes, answer it. So we've got define the issue already. You got measure, you got analyze, improve, and control. If you can't remember Six Sigma, please do look previously in the video or look at the first year video where I've gone through it in a little bit more detail as well. Next question. So define the term quality assurance and quality control. So 4 marks, 2 marks each, definition and an example needed. So again, pause video, 4 minutes, have a go answering it. Okay, so definition. So procedure and policies put in place to reduce waste and ensure manufacturing products are produced accurately with acceptable tolerances. So you can give examples to make your point a lot more worthwhile. So accurate dimensions to make sure things are done correctly, setting temperature tolerances while doing forming, checking molds, checking cutters to check that they're done correctly, to check that they are sharp enough for the job that they want to do, check that you've got the right drill bit to make the hole that you want, anything like that. Next, quality control measures are put in place when manufacturing products. Suggest 2 quality control measures a manufacturer could carry out. So, again, 2 marks, no explanation needed. So, anything you could do is like measuring devices, so using like vernier calipers, digital angle finders, go, no-go, gauge, things like using jigs, molds, templates, CNC machinery, checking random sampling of products, using assembly jigs, failure testing, destructive testing, non-destructive testing. So any 2 of those would have been fine. And then last question, with reference to a product which we are familiar with, explain the different quality assurance and quality control procedures that would be suitable for each of the following production volumes. So one-off production, large-scale production of 100,000 units on an assembly line. So 28 marks. So you got about 2 things. So that's 14 marks each. So really that's 7 points with an explanation. Remember, you can use diagrams if you wish, but it's not required, but it is easier to answer with some diagrams. So 28 marks, pause the video, we'll go through. So what I would do first of all is I would give a definition of what the term quality control and quality assurance means, and then, so that will give you a couple of marks first of all, and then for the product, obviously depending on what you've picked matters. So then you talk about quality assurance, could be things like CAD simulations, use of jigs to ensure things are done accurately, setting of automatic, much like CNC machinery to do certain jobs, setting suitable tolerances, checking those tolerances along like with gauges and things like that, which then leads to your quality control things. So using measuring gauges like no-go, or using vernier calipers or digital angle finders, checking batches, checking samples to make sure that they're done accurately. So with, again, we've said quite a few times now, anytime it's with a product of your choice, just make sure it's something that you can be familiar with. You might say something like a Coca-Cola bottle, biro pen, anything that's relatively simple but you know that can be checked. If you've got any questions, if you can send me an email or message on Teams and I'll get back to you.